and that will be there. And okay, so without further ado, I will stop streaming there. And I will just ask Ashley Davis to jump on. There he is.
Hey, can you hear me?
Yes, absolutely. Welcome. Thanks very much for submitting this talk, and I'll just hand over to you now.
Well, thank you, Kevin, for continuing to run this meetup, even though we can't meet physically at the moment.
It's my pleasure.
And hi to everyone out there. My name is Ashley Davis. I'd like to welcome you to my home office. So this isn't a virtual backdrop. This is actually where I work most days. Even before the virus hit, I work from home quite a lot. And that said, I hope everyone out there is okay. Like these are pretty difficult times, and I hope everyone's doing okay and just kind of holding in there until we can kind of hopefully sometime soon, get back together face to face and have this meetup in person again. That'd be great. So I'm the CTO of a startup called Sortle. I'm also the developer of my own product called Dataforge Notebook. I'm the author of 2 books, Data Wrangling with JavaScript and Bootstrapping Microservices. Tonight, I'm going to talk to you about something I learned recently, about Babel. So Babel is a JavaScript compiler. It's a very popular one, and I don't actually use it. So normally in my coding, I would use Typescript, and I'll use the Typescript compiler, not the Babel compiler. But I do use Babel inside my product, Dataforge Notebook, to compile basically code that users have in their notebooks. I'll show you an example of that in a second. And I recently found myself wanting to do something more sophisticated with the compilation pipeline. So I learned how to create custom Babel plugins. So that's just a little snippet of JavaScript code that basically you can inject into your compiler pipeline. And you can do heaps of interesting stuff there. And it's a lot about how Babel works as well. So Babel provides you with a plethora of basically plugins for doing all sorts of JavaScript features and compiling them back to backward compatible JavaScript code. And you can write your own JavaScript code that basically just fits into that pipeline, and you can use it to modify code and add your own features to languages even. It can be that much. So at the end, I'm going to show you what I did with my custom plugin, like the end result of the code that I wrote. That's a little bit complicated to start with, so we're not going to start with that. What I'm going to do is I'm going to give you a little bit of background as to why I needed this and what I'm going to use it for. And then I'm going to give you a demo of Babel. So for people who haven't seen Babel before, I'll give you a quick demo so you can get an idea of how to use it and what it can do for you. And then I'm basically going to show you how I learned to write custom plugins. So it's not as hard as you might think. They got some great documentation, and I'll give you some resources. I'll put some resources up on meetup.com as well, so anyone else who wants to follow up on this later can. Okay, I'm just gonna share my screen now so everyone can see what I'm doing. Cool. So this is the landing page for Dataforge Notebook. I've actually got some big news to announce tonight. So I've been developing this project on the side of normal contracting, startup work and stuff that I do. I've been developing it for about 2 years now. So it's gotten pretty sophisticated, but I'm now gearing up to release a free version of it. So I'm keen to see who's interested in that. If you are interested, I'm going to give a demo in a second. Please jump on the landing page here. It's dataforgenotebook.com. And if you give me your email address, I'll send you an email when the free version is ready to go. It's going to be in the next couple of months. Also, at the end of this page, you can find my email address and my Twitter handle if you want to get in touch and have a chat. Cool. So this is the web page for Babel. So as I said, Babel is a JavaScript compiler. Great documentation, and it's really easy to set up and use. If you follow through to the setup page here, you can basically pick how you want to use Babel, and it'll give you really good instructions on how to set it up. So this is basically just how I learned this. I'm going to show you this again a bit later, but this is the Babel plugin handbook. So this was really, really handy to kind of learn the basics of how to put it together. And I'm basically, for the simple example that I want to give tonight, just to show how easy this is to do, I'm just going to basically give a summary of what's in this. So, I mean, it's quite a long document, but I'll give you the cut down version of that as quickly as I can. Actually, I'm just going to set a timer because I don't want to go too over time on this. I want to keep this quite short. So I'm going to just give you a bit of background. So this is a notebook in DataForge Notebook. It's basically markdown cells interspersed with JavaScript code. If you know Jupyter Notebook, this is basically like Jupyter Notebook, but for JavaScript. You can get some pretty interesting visualizations, like you can preview tabular data, a couple of examples here. You can do charts with this fairly easily. And one of the latest features is maps. So you can do kind of map-based visualizations here as well. And I can run the code here by running this entire notebook, or I can run each code cell individually. So this is a great way to prototype JavaScript code and visualize what you're doing at the same time. So I've got a simple example that kind of demonstrates what I wanted to do with my plugin. So this is an example JavaScript notebook with two cells. The first cell here, we've got two variables. We're printing out X using the display function. It's all asynchronous aware. So I've set, just for the purpose of an example, I'm doing a set timeout. So after 1 second here, we're basically going to reset the X variable to an array. And then there's another code cell here that just displays X. So if I just run this fresh, you can see when I run the whole notebook, I get 1 printed out here in the output. So that's from that display X. And over here, I get 1 printed out in the second cell. So it's run it like an entire JavaScript, like just one JavaScript file, basically. I can run this, this cell by itself. This time it produces a different result. So you can see it's printed out an array. And that's because in the asynchronous code here, like basically like a second after we started it, we've set this X to 1, 4, 10, like an array of values. So what I had to do here to make this work was basically to run code in the compilation pipeline that would extract these variables and the values of these variables at certain times. So it does it after the code cell has run, and it also does it after all asynchronous operations for a code cell is done as well. So it captures that value. And the benefit of this is that then you get to kind of rerun, you can run your whole script, your whole notebook, and then you can run individual cells and actually reuse the variables that were captured. This is quite an advanced use case. I'm actually going to show you what that notebook looks like in JavaScript code now. So I've just sort of set up this example previously. I'm just going to show you it in Visual Studio Code. Oops. Let's just do that. Okay, so on the left here, basically, you see the code from the notebook, basically just smashed together in a JavaScript file. So that's the code for the first cell. That's the code for the second cell. Now on the right here, you can see the generated code. So basically I've wrapped this whole thing up in JavaScript that I can compile. I can actually put this through Babel. And I'll show you the compiled version of it in a moment. But you see that I've wrapped each cell here in its own function, and that's how I can get async await to work. We've got the code for cell 1, and we've got the code for cell 2. And you can see that I've injected some extra functions here, capture locals. That's capture locals for the first cell. This is capture locals for the second cell. Now, what I'm doing here is basically, you can see this object here. What I want to do as part of the compilation pipeline is to magically take these variables up here, the X and the Y, and inject them down here. So I've got a little kind of mechanism that's kind of generated into the code to be able to capture the values of variables as the code is running. And now I'm going to show you the, let me just rearrange this a bit. I'm going to show you the compiled version of it. So now on the left, we've got the generated code with capture locals. And after putting it through Babel with my custom plugin, you can see here that it's automatically captured the names of the local variables and their values so that basically they can be recorded in memory to be used later. So apologies if you're not following. This is probably quite an advanced use case, but I'm gonna break it down to something simpler now, hopefully. So the first thing I'm going to do basically now, let's just reset to something real simple, right? I'm just going to show you the real absolute basics of how you go about using Babel and compiling some JavaScript code for it. So I've got this JavaScript project here. You can see I've got just a real simple script here that's got a hello world in it. I've got this as an async function. And now the only reason I'm really doing that, because I'm not making use of async here. The only reason I'm doing that here is so that I can kind of show you what Babel does to this. So async, of course, isn't available in many old browsers or old versions of Node.js, say. And one of the things you can do with Babel is basically backward compile to an older version of JavaScript that has all that basically factored out so that you can run this code on an older platform. Now, to use Babel, first things you're going to do is basically install the Babel CLI. That means we can basically run compile our JavaScript code on the command line. There's the Babel core, so that contains the the parser, the compiler, all that kind of stuff, just wrapped up in that. And then there's this thing called Babel Preset NV. So that's a preset environment. It's basically a collection of plugins that implement the JavaScript ES15 standard, I think. So there's a whole bunch of plugins. I don't know how many, but there's a whole bunch of different plugins that basically make up that standard. And if you install this one package, you basically get all that in one go. Now, what we've got here is the Babel Rc, or the Babel configuration file. So this is fairly minimal, but all it's saying here is that we want to include that preset. So that's what basically configures the compiler for us. Now, back in package.json, we've got a build script here. So this is where we're actually running Babel. And it's basically saying to compile code in our source directory to our dist directory. I'm going to run this now just to show you what it does. I've actually got a dist directory here that I generated earlier. I'm just going to delete that so I can show you it working from scratch. And I'll do Npm Run Build. So this is taking that index.js now, and it's compiled it into another file. So I'll just take this out so we can kind of compare side by side. So we've got the original index.js. We've got our console log on the left here, and you can see where that is on the right here. Now, there's a lot more code on the right here. So you can see that, I've added this async keyword. That's generated a lot of kind of old-fashioned, say, JavaScript code there that can basically run that for us on old browsers and old versions of Node.js. So this is what the compiler does for us. It allows us to basically use all the latest, greatest features of JavaScript, but we can compile that into a version that we can run pretty much anywhere. So hopefully this is all making sense so far. Before we can look at how to make a custom plugin, we do need to cover a little bit of compiler theory. Let's make this pretty quick. So I've been a developer for over 20 years, and I've been a compiler nerd from way back in the early days. I loved understanding how compilers worked, and I studied it at university, and I've made a couple of hobby compilers over the years. I was just looking at the definition of abstract syntax tree on Wikipedia. So this is the main thing that you have to understand for what I'm showing you tonight, is what an abstract syntax tree is. Also known as an AST for short. But if you're interested in this stuff, this sounds interesting, please have a look at this on Wikipedia. I basically pinched their graphic to use to try and have a go at explaining what this means. So an abstract syntax tree is a data structure that represents like a formatted version of your code in memory. So when you run a parser, which is a part of a compiler, it's going to take that raw code file and it's going to turn it into something that looks a bit like this tree here. And you can see in this example here down the bottom, we've got a bit of pseudocode there. That's not JavaScript. I don't really know what that language is, or it's probably just kind of a pseudocode language. But this is meant to represent, this tree is a data structure that basically represents that code. And of course, the reason that we do this, if you're working in sort of compilers, the reason you do this is because it's a lot easier to work with a tree data structure than it is to work with a raw source code format. So the process of parsing basically turns your raw code into a data structure like this, and it's a lot easier to manipulate, to modify, to extend, to make changes to than it would be if you were trying to if your code was trying to modify a source file directly. So what I'm going to be showing you with Babel is that Babel gives this really amazing JavaScript parser, and you can only really appreciate it probably if you've tried to write a parser yourself, because it's pretty difficult, pretty time consuming, there's a lot of code in it, but you get a really great JavaScript parser built into Babel. And then all you really have to do is put in the code that does whatever you want to do to this tree. So you can have then, processing code within your compilation pipeline. And it gives you so much power to extend your build pipeline, your build process, things like that. So hopefully that abstract syntax trees didn't really go over anyone's head too far. I'm going to show you an example in code now, and you'll see that when you actually see this working, hopefully it'll make a lot more sense. So I've actually prototyped this code previously in DataForge Notebook. So I've got an example notebook that comes with DataForge Notebook. This is the JavaScript parsing example. So I'm just going to use it as my cheat sheet, but I'm going to go through this and just pull out each individual bit of code so I can kind of explain it as we go. I'm going to do this through DataForge Notebook, but I mean, this is just regular Node.js code. So I'm just using DataForge Notebook because it's a good demonstration of DataForge Notebook and because it makes it a little bit easier for me. So to start with, we need some code. And actually this comes from the Babel plugin handbook. So you can see here that I'm just using basically the function that they provided. So this is a simple JavaScript function that can, square a number and return the result. So I've defined that as a string in JavaScript here, and that's the code that I want to put through the Babel parser. So I'll just find my cheat sheet here, and I'll just get the next bit of code that I want to copy across. Oops. So what I'm doing here is I'm importing Babylon from the Babylon NPM library. So Babylon is the parser that powers Babel. So it's like what we're looking at here is not Babel per se. I'm showing you now some of the lower level libraries that actually power Babel. So Babylon has this parse function. So all we need to do is give it some code. You can see that. And then what we get in return is our abstract syntax tree or our AST. Now I'd actually love to be able to show you something that looks like this diagram here, but I mean, this would be pretty tricky to generate. So what I'm going to show you is going to look more like JSON data, I guess. I'm just going to run this notebook. So you can see here in the output for this cell, we've got an abstract syntax tree. We've got the root of the tree. There's a file node. Under the file node is a program node. We've got the body of the program here, the function declaration. So the function declaration here is going to be the declaration of that square function I just showed you. So under function declaration, we've got an identifier, and that is the name of that identifier is square. So that identifies the square function that we're declaring. We've got parameters here, parameters to the function, the body of the function here. So that's a block statement. Under here, we've got a return statement. And then what we're returning is the result of a binary expression. On the left-hand side of that expression, we've got an identifier called n. And then the operator we're using here is multiply. So we're basically doing n by n here. So on the right of this equation, we've got another identifier n. So this is what represents the program in memory. And I mean, this looks pretty complicated, right? It's a pretty small JavaScript function, but it generates this massive data structure. And you can imagine what this would look like if you put like an entire JavaScript file or an entire JavaScript program through your compiler. And you can imagine this tree would get pretty huge. So now we've got the abstract syntax tree in memory. We can make some changes to it. So now we're going to be making use of the traverse function from the Babel traverse library. So we're traversing this tree. We're using what's called a design pattern called the visitor pattern here. So into the traverse function, we're passing our tree. And this is a special kind of format that you get to use with this library. And you could just pass in a function here as well, and it would execute that function for every node in the tree. But what we're doing here is saying, I'm only interested in identifiers. And then within that function, we're going to make a modification to the tree. So if we see an identifier named N, we're going to replace it with an identifier named X. So this is pretty simple stuff. We're just basically, in our compilation pipeline, we're basically changing the name of a variable. So pretty simple stuff, but you could imagine if you were like writing an IDE, like Visual Studio Code or something like that, this could actually be the starting point of like a refactor rename function, something like that.
So just to interrupt, Ashley, can you enlarge the text size? We're only running 720p on YouTube, unfortunately. That will be a lot better. Yeah, I think so. Thank you.
Great, cool. I can make all this code available on GitHub as well, if anyone wants to look at it later.
Awesome.
So the last bit of this particular part of the demo is using the Babel generator. So we're using the generate function from this other low-level Babel library. And all we're doing is we're passing the AST into this function, and it's going to generate JavaScript code back for us. So I'm going to run this now. And the expectation is that we're going to have changed our code using this procedural technique. So you can see on the output here, we've got a square function that takes an X parameter and it returns X by X. Now, if we just revisit the start of this notebook, you can see that the original function was taking an N parameter and returning N by N. So this is just a nice little way to kind of prototype some code to learn how to, to learn how to parse JavaScript code, to learn how to traverse and modify an AST, and to generate JavaScript code back from it. For this to be more generally useful, though, you then have to kind of wrap this in a Babel plugin. I'm going to show you how to do that now. I'm just opening another Visual Studio Code project that I prepared earlier. Now, this is exactly the same as the kind of the first example that I showed you, right? We've got Babel installed in our package.json. We've got a build script here. We've got an index.js. It's got, instead of having hello world, though, it's printing out a squared number. So you can see the square function here. And we're calling the square function here, and then we're just printing the value of it. And I'll show you that during the compilation process, basically we can kind of rewrite this square function to have that X instead of an N. Now, my plugin is in this subdirectory here. Hopefully everyone can see this. So my Babel plugin. So normally if you've used a Babel plugin that someone else has provided for you, you've probably installed that from npm, and you've basically wired it in as an npm module. But this is a way that you can basically wire in a custom plugin within any project. You don't even need to publish it. So it's a great way to experiment and to get it right, and just to use it privately if you want. You don't even have to publish these things, obviously. So the way we wire that in is through the Babel Rc. So you can see here that in my Babel configuration file, I've added a list of plugins now. You could have as many plugins as you want. And I've referenced my Babel plugin using /. So basically it's a relative path to my plugin in this local directory. Now, if it looked like that, it would have to be like an npm module. It would have to be installed through npm. But because I'm referencing it as a subdirectory, I just have that plugin basically included in this project. Now let's look at the code for that. So this code is very similar to what I just showed you. we're defining a visitor here that's going to visit every identifier in the abstract syntax tree, and it's going to check if there's an N, it's going to replace it with an X. Now, this is just a normal JavaScript function. It's kind of like a factory function for the plugin. So it gets called with this Babel object here. We're not actually really making use of that in this simple plugin, but it's got like the APIs that you need there for doing, traversals, all sorts of other stuff that's useful when you're writing a plugin. But all we need to do here is basically just return this object. It specifies the visitor, and it walks the abstract syntax tree, and it does this conversion for us. So I ran the build process for this earlier, and it generated this file. And so you can see the compiled version of our square function basically works with the name X now. So again, a pretty trivial example, but a lot of really advanced stuff in Babel is implemented using plugins that look a bit like this. And I think I'm ready now to show you what my final plugin looked like. So I'm just going to make this smaller for a moment just so you can see the whole thing in its entirety. So this is my custom Babel plugin that lives inside Dataforge Notebook that is capable of finding this function called capture locals. It walks backward through the AST to find variable declarations, and then it generates like a JavaScript object expression that can basically capture all the names and the values of these local variables. Now I'll zoom in again a bit so we can look through this. This is actually TypeScript code, right? So this is TypeScript code that gets compiled to a JavaScript plugin for Babel. So we've got some kind of TypeScript imports up here for importing type declarations and that kind of things. And you'll see some, TypeScript typing throughout this. So TypeScript's really good for this kind of thing as well, because you get all the static types for the whole Babel API, and it makes it a lot easier to discover what's available and what you've got there to work with. So what I'm doing here is we're returning a visitor to walk an abstract syntax tree of whatever is being compiled. So at this point, it's very general, right? So whatever is being compiled, Babel is going to run this traversal and this visitor on it. We're looking for call expressions, and there's a bit of a qualifier here that the calls we're looking for are calls to the function capture locals. And then this chunk of code here, it's basically using some Babel APIs to walk backward through the AST, the abstract syntax tree for this entire program, and find all the variable declarations that are on the same level as the call to capture locals. And what it's doing is it's basically here, it's just storing the name of each variable in an array. And then we've got a nested traversal here. So we're doing another traversal here, but this time underneath the call to capture locals. So we're looking for the object expression, or the JavaScript object expression that is being passed to capture locals. And then we're modifying that. So we're modifying that so that it passes in, the names basically and the values of the local variables. So, this is a fairly advanced use case. I'm sure there's plenty more advanced plugins than this, and you can see all the code for these things on GitHub as well. So there's great stuff out there for you to look at. Let me just remind you though of what the end product looked like. So what we're doing here is we're taking this code on the left. We're compiling this code on the left here through Babel. It's looking for capture locals. When it does that, it's walking backwards through the AST, picking out the variable declarations, and then it wants to populate them basically into this object expression right here. And so you can see the result of that on the right here, and this is the compiled file. So that's where it's injected the names and the values of the local variables. So that's about all I've got for you tonight. I'm going to unshare my screen now, and happy to take some questions if there's any.
Thanks very much, Ashley. That's awesome. There are a few questions.
How do I unshare my screen?
You hover over the particular screen that's being shared, and there should be a thing that appears on the bottom or the top of that screen.
Oh yeah, got it. Cool.
You got it. Awesome. Cool. So let me just dive into the Slido feedback here. We've got 3 questions. The first one there is there any way to graphically visualize the AST that Babel evaluates?
Not that I know of, although I really do want to find that. So if I do find something like that, I'll probably tweet about it. But so far, you know, I Googled for ASTs and images of ASTs so I could show you something. And all I could find was like sort of handcrafted visualizations, nothing that was automatically generated as far as I can tell. Yeah.
Well, something that could read that JSON format that you demoed for us would be really interesting. So I'd say it's definitely something you can do, depending on what the use case is that people are chasing here.
The thing about that as well is that those ASTs get pretty complicated pretty quickly.
Yeah.
So, you know, actually making a meaningful visualization out of it could actually be quite difficult.
Yeah,
because
absolutely.
if you just take any random JavaScript file from your code and do that, like it's just going to be a huge mess, a huge graphical mess, unless someone's sort of gone in and cleaned it up. One thing you should look at, I don't think it's a visualization, but there is something out there. I'll put a link up to it later. It's called the Babel plugin playground, where you basically you get to type some code. There's a version of this for TypeScript as well as, actually, if you're interested in TypeScript. So you can type a bit of TypeScript code. You get to visualize like a kind of a JSON version again of the AST. But it also can show you, like, you know, you can type in a little plugin and you can see what the compiled output is like. And that's a great way to experiment with Babel as well. I'll put a link up later.
Sounds good. Next question is, does everyone use Babel? Should it be used for every project? Is there an alternative, or is Babel the only build parser for JS?
No, there's a bunch of these things out there. But personally, I didn't use anything. Like one of the things I loved about JavaScript when I first started working with it is that you didn't need a build process or a compiler or anything like that, and it felt very liberating. But, you know, eventually, you know, doing more and more professional stuff in JavaScript, and, you know, having a background in C++ and C# and these typed languages, you know, TypeScript, you know, ended up really appealing to me because I could take a bit of, you know, the dynamism of JavaScript and mix and match that with static typing, you know, as I saw fit. So I love working with TypeScript, and normally I use the TypeScript compiler, which, you know, it seems very popular as well, but Babel is just fantastic. Like it's, you know, they're up to version 7 or 8 or something like that. So it's pretty mature. It's pretty stable, great documentation, heaps and heaps of code for plugins available. So, you know, apparently you can do TypeScript and Flow through Babel as well. It's just different combinations of plugins. It's really powerful.
There you go. So that leads into the other question. Does the TypeScript compiler support the custom transformations like this too? So I'm assuming then you can go the Babel route.
Yeah, not that I've seen. So I've done this same kind of thing with TypeScript, and it's really painful. Like TypeScript is a great language to work with, but working with the compiler API, you're going to find yourself looking at a lot of complicated TypeScript code. They don't have very good documentation. You know, you'll probably find yourself like I did, you know, talking to other people on the internet who've worked with the TypeScript compiler, asking them how they did it, getting examples from them and stuff like that. Babel's a breeze compared to that. Like I recommend, in fact, in DataForge Notebook for version 2, I'm tempted to rip out the TypeScript compiler and replace it with Babel, but with TypeScript plugins. So it's just been really nice to work with, you know.
Sounds great. So the last question that I've got here is, so you are saying we can do data analysis with Babel?
Well, I wouldn't quite say that. What I'd say is that you could do data analysis with JavaScript. I mean, that's been my thing for quite some time. You know, Babel's a compiler. Like, you know, it'll take your language from kind of modern, you know, JavaScript and basically compile it so you can use it basically in all the old browsers old versions of Node.js, stuff like that. You always get to stay on the cutting edge of JavaScript if you're using Babel. But that in itself is nothing to do with data analysis. I mean, that's just something that I tend to do. Obviously, you can use JavaScript for anything these days. You know, it comes from the web, but you know, Node.js came along. It was server. You can write mobile programs using JavaScript now. I've been pushing, you know, data analysis and transformation stuff in JavaScript. Of course, JavaScript's always been great for doing interactive web visualizations. You can use JavaScript for anything, and Babel's there basically just to support you. You know, it's not required, not necessary. It's just there to support you if you see value in it.
Absolutely, yeah, important distinction to make. Thanks very much. Well, that's all the questions that we've got tonight.